The History of Quantum Mechanics, Part 4, Niels Bohr.
Niels Henrik David Bohr was born on October 7, 1885, in Copenhagen, Denmark. Bohr came from a well-educated family. His father, Christian Bohr, was a professor of physiology, and his mother, Ellen Adler Bohr, came from a prominent Jewish banking family. Bohr attended the University of Copenhagen, where he earned his master's degree in 1909 and his doctorate in 1911, with a thesis on the electron theory of metals. Academic career and key contributions. After completing his doctorate, Bohr worked with J.J. Thomson at the University of Cambridge and later with Ernest Rutherford at the University of Manchester. His time with Rutherford greatly influenced his thinking. Development of the Bohr model of the atom, Bohr model, 1913. Rutherford's influence. Building on Rutherford's nuclear model of the atom, Bohr's model introduced the idea of quantized energy levels, explaining the stability of atoms and the spectral lines of hydrogen. Atomic structure. Bohr proposed the model of the atom where electrons orbit the nucleus in specific quantized orbits. Electrons could only occupy certain allowed orbits and could transition between these orbits, emitting or absorbing energy in discrete amounts or quanta. The Bohr model was a significant step forward in atomic theory, merging classical and quantum concepts and laying the groundwork for future developments in quantum mechanics. Contribution to quantum mechanics. Complementarity principle. Wave-particle duality. Bohr introduced the principle of complementarity, which states that particles such as electrons exhibit both wave-like and particle-like properties, but these properties cannot be observed simultaneously. The nature of the observation determines whether wave or particle characteristics are observed. Philosophical implications. Complementarity was a central concept in the Copenhagen interpretation of quantum mechanics, emphasizing the contextual nature of measurement and the limits of classical descriptions in quantum phenomena. Copenhagen interpretation, development. Bohr was a key figure in the development of the Copenhagen interpretation of quantum mechanics, along with Werner Heisenberg and others. This interpretation posits that a quantum system remains in a superposition of states until it is observed, at which point it collapses into a definite state. Influence. The Copenhagen interpretation remains one of the most widely accepted interpretations of quantum mechanics, shaping the philosophical and scientific discourse of the nature of reality and measurement. Later life and work. Bohr was awarded the Nobel Prize in Physics in 1922 for his contributions to understanding of atomic structure and quantum theory. In 1921, Bohr founded the Institute for Theoretical Physics at the University of Copenhagen, which became a leading center for research in quantum mechanics and attracted many prominent physicists. Bohr was involved in the Danish resistance and helped Jewish scientists escape Nazi-occupied Europe. In 1943, he fled to Sweden and then to the United States, where he contributed to the Manhattan Project. After the war, Bohr advocated for the peaceful use of nuclear energy and international cooperation. He returned to Denmark and continued his work in theoretical physics. Personal life and legacy. Bohr married Marguerite Norland in 1912, and they had 6 sons, 2 of whom died young. One of his sons, Age Bohr, also became a prominent physicist and won the Nobel Prize for Physics in 1975. Bohr was known for his collaborative spirit, intellectual humility, and commitment to scientific inquiry. He was a mentor to many leading physicists and played a crucial role in fostering the development of quantum mechanics. Niels Bohr died on November 18, 1962, in Copenhagen, Denmark. Legacy. Quantum mechanics. Bohr's contributions to atomic structure and quantum mechanics were foundational. His development of the Bohr model and the principle of complementarity were key milestones in the field. Copenhagen interpretation. As a leading proponent of the Copenhagen interpretation, Bohr influenced the philosophical understanding of quantum mechanics and the nature of scientific observation. Scientific leadership. Bohr's establishment of the Institute for Theoretical Physics created a hub for cutting-edge research and collaboration, attracting many of the brightest minds in physics. Peace advocacy. Bohr's efforts to promote peaceful use of nuclear energy and international scientific cooperation reflected his commitment to ethical responsibility and global security. Bohr's pioneering work in quantum mechanics, his philosophical insight, and his dedication to scientific collaboration have secured his legacy as one of the most important physicists of the 20th century.